Herzlich willkommen zu unserem Grundkurs
Welcome
Wasserstoff.
to our introduction to hydrogen. My name is Stephanie Groll. I am the head of the Department of Sustainability Policies at the Heinrich-Böll Foundation. Well, introduction to hydrogen. Hydrogen is high on the agenda at the moment, and I would even say that very rarely has something been talked about that much in the course of the energy transition than hydrogen. And so it's high time to give an introduction to hydrogen, to talk about the basics. And in this introduction, you will learn more about the technology, its strengths and weaknesses when it comes to climate protection and energy transition. And it will also inform you about political positions in order to better assess the situation at the moment. And we will thirdly also show what kind of framework conditions, political framework conditions or instruments are needed so that a sustainable hydrogen economy can develop. When I say we, I am predominantly talking about our speaker for tonight, Maike Schmidt. You will see her in a moment. Maike Schmidt is the head of the Department of System Analysis at the Center for Solar Energy and Hydrogen Research in Baden-Württemberg, which is in the south of Germany for our international listeners and participants. And Maike Schmidt has been focused on hydrogen for more than 15 years. So she has focused on the topic long before it has reached the top of the agenda. And she knows about the technology quite well, but also the political discussion. So this makes her the ideal speaker for this introduction. We will start shortly. And at the moment, I try to speak relatively slowly because we have an English interpretation. The seminar will take place in German, and we will also focus on Germany and Europe, but there will also be some room for international questions from a global perspective. So should you have a question, please write them into the Q&A tool in Zoom, the F&A tool, but it can also turn on your video and your sound. And we are quite happy if you do this, because then we finally see also a human being. So if you want to ask a question live, so please enter a V before you enter your question into the Q&A tool. So Philippe, our technical host, will now show you the questions that we would like to ask you. This is a little poll, a little survey. So we would like to know how we can improve these kind of seminars. So we would like to know, first of all, where do you live, on which continent or in which country? And then more precise, where exactly do you live? Because we also try to get out of this conurbation bubble, and you can of course decide yourself whether you live in a small or medium-sized city. Then of course we're also interested in your political background or your connection to hydrogen and how you learned about the seminar. So there are 4 different questions. If you scroll down, then of course you can only select 1 item per person. We will give you another 10 seconds for this little poll, and then we will start. Philippe, I think we can now turn it off. Okay, so here we see that we have a strong focus on Germany. You can see it yourself. So most people in the audience are from Germany, some from Europe, South America, and others. And we have good distribution also in terms of the political background. Thank you very much for participating. And now I pass the floor and the screen to Maike Schmidt. Good evening, Ms. Schmidt. Thank you very much for participating once again and for giving this introduction once again. So the screen is yours.
Ja, herzlichen Dank.
Oh, thank you very much, and good evening also from my side. I'm quite happy that there are so many participants tonight who would like to learn more about hydrogen and thus want to participate in the first part of the introduction to hydrogen, which will deal with the production and application of climate-friendly hydrogen. As this is an introduction, I would actually like to start right at the beginning. Many of you might still remember hydrogen in the context of your chemistry classes. And when you look at this system here, at this periodic system, you can see that hydrogen is the element with a symbol H, which stands for hydrogenium, a water producer, and the atomic number is 1. So this is the chemical element with the lowest atomic mass. And you might also still remember that your chemistry teachers told you that under the conditions on this planet, usually hydrogen only is available in compounds and molecules. So 2 hydrogen atoms, for example, together, as you can see in this drawing on the left-hand side. Hydrogen is a colorless and also odorless gas, and usually this is the way it is being found on this planet. When you also think of hydrogen, you might also think of the picture on the right-hand side. You might know that it is used as rocket fuel, but all the other applications of hydrogen today might be less known to you. And this is what we would like to take a look at now, because hydrogen is or already plays an important part of our economy today. We have a global consumption of approximately 70 million tons, which is amounts to 140 billion euros if you apply 2 euros per kilogram hydrogen, which is Ms. Schmidt. Unfortunately, I have to interrupt you. Could you turn the microphone a little bit away from your mouth? Okay. Thank you. I will start again. So the 140 billion euros per year is approximately the value that is attributed to hydrogen when we assume that 1 kilogram of hydrogen costs approximately 2 euros per kilogram. This is correct if you produce hydrogen based on natural gas, and the current price spikes that we see in Europe at the moment are not yet included here. The energy demand corresponds to approximately 1.4% of the world's energy demand that is needed to produce this hydrogen, so it's quite a lot. But where is this hydrogen being used? 65% of the global hydrogen demand comes from the chemical industry, and the ammonium production is the main consumer, and predominantly the fertilizer production, but also in the production of polymers, so plastics, we need hydrogen, also for resins and others. And another quarter, or 25% of the global hydrogen demand, comes from refineries. And here we have crude oil via hydrocracking and also hydrotreating. It is transformed into the products that you can buy at the gas station or are being delivered by heating oil suppliers. 10% of the hydrogen demand comes from other industries, which is, for example, the steel production, where hydrogen is used nowadays for tempering and hardening, or also as a protection or forming gas. And I will talk about other areas later on. In the industry in general, we also see an application in the semiconductor and also in some parts of the food production. For example, when it comes to dehydrating fats, if you want to produce margarine, for example, or for example, in the production of glass, you can only do this together with hydrogen, or also when it comes to the cooling of generators, hydrogen plays an important role. Today, hydrogen is usually produced based on fossil fuels. A lot comes from the reforming of natural gas and also oil and coal. and a remaining part comes from the electrolysis or chloride alkali. But this is not yet really green hydrogen that is being produced here. So this shows already that we are faced with huge challenges if we want to make hydrogen climate neutral. Let's take a look at Germany. Here, the distribution is a little bit different as we've seen right now. So in Germany, we have a hydrogen consumption of approximately 1.6 million tons per year, and 40% of it go to the refineries for the refining of mineral oils, as we've seen at the global scale as well. And 25% in Germany go to the ammonium production, which means chemical industry, and 20% to the methanol industry. So once again, the chemical industry. So the distribution is similar to the international level. However, the figures slightly vary. In Germany, the main part of the hydrogen comes from the reforming of natural gas, and you can see it on the left-hand side, the chemical reaction, and you can also see that it also emits CO2, so carbon dioxide, and we also have the petroforming, where we also emit carbon dioxide, ethene production, where we have hydrogen as a byproduct, and also the chloralkali electrolysis. And here you can also see the main building blocks of hydrogen, which are fossil in nature. And if we take a look at the international level, we see that hydrogen as a raw material for the industry makes a huge contribution to the greenhouse gas emissions today. You can see here the global hydrogen production with 830 million tons per year in 2017 led to larger carbon dioxide emissions than in Germany with 797 tons. So this actually creates a huge challenge if we want to have a climate neutral processing here. Now I will take a look at the infrastructures in connection with hydrogen. We have different product pipelines for nitrogen that are in operation. And here we have, for example, the pipeline in the Ruhrgebiet, which is in existence since 1940, and it has a length of approximately 230 kilometers, but it's a product pipeline in order to transport the product hydrogen, and not like natural gas as an energy carrier in the large transport pipelines via huge distances. This is not yet available for hydrogen. How about the future? In the future, we do not only want to use hydrogen as a raw material for the industry, but also as an energy carrier. And you can see here in these two road maps, schematic roadmaps, the hydrogen roadmap Europe on the left-hand side, and in the middle, the roadmap to US hydrogen economy from the US. And you can see here that the expectations are not even in an ambitious scenario that a lot is going to happen by 2030. But if you take a look at 2050, we see 325 megawatt hours of hydrogen in the existing industry. And in the year 2030, we have 564. So it's a doubling, and till 2050, we are headed towards 251. And of course, the areas where the hydrogen is being used are very important here. First of all, as a new raw material in the industry, then as an energy carrier in the industry for heating and also electricity generation or heating of buildings, of course, then in transportation, and also for the electricity generation and also a storage. This is what the European strategy envisions for 2050. Till 2030, the largest part should lie in the field of energy production, but also in the field of transportation and renewable energy supply. We also want to see a development in this ambitious part here. The European hydrogen roadmap also assumes that this is not only connected with a huge cut in the greenhouse gas emissions, 560 million tons per year of carbon dioxide, but also huge revenue possibilities of 820 million euros, and also many jobs that might be created by the year 2050. So this is actually an economic factor that cannot be neglected. And if you take a look at the picture of the US hydrogen economy in the middle, then it looks quite similar. So here in the areas we've already mentioned, hydrogen is supposed to be used. If we now take a look at what it means, then we have to say that what we already consume as hydrogen today, and if this is supposed to be climate neutral, so provided we equal climate neutral with the generation of hydrogen via electrolysis with renewable electricity, that means that we need 500,000 megawatt hours electricity at a utilization capacity of 6,000 hours per year. And this is in line with an electricity need of 3,000 terawatt hours. And this is today's energy consumption or electricity consumption in Europe. If we take a look at the European hydrogen strategy and the US strategy, then we get an idea of what this actually means in terms of the building up of a renewable network if we want to implement these kind of scenarios. Of course, we are not alone in Europe when it comes to the strategy. Of course, the American hydrogen strategy has already been mentioned, but there is also Asian hydrogen strategies. Japan, for example, and Korea were the first ones to set up and publish hydrogen strategies, but also Australia and also the South American countries like Chile and Brazil are very active in this hydrogen context. And the European countries are many are very active, but we can also see that some activities in the field of today's mineral oil exporting countries like Saudi Arabia and South Africa also sees some opportunities here in the field of hydrogen. And hydrogen also as a future export product for those who have sufficient potential or also for their own energy consumption. And this leads to an intensive international innovation competition, which Europe would like to decide in favor of Europe. But of course, this means that Europe has to make a huge effort. I just said that if we want to have a climate-friendly hydrogen, and of course, there's a huge debate about what it actually means to have climate-friendly hydrogen. And this is why I brought along the color coding or color theory of hydrogen, just to give you a rough overview of what we are talking about when we talk about the individual hydrogen. So green hydrogen is hydrogen that is generated via renewable energies, via electrolysis or biomass. Sometimes people also mention biomethane. Some say that this is orange hydrogen. I kept it in green here in order to avoid too many colors. Turquoise means that it's a thermal split of methane via methane pyrolysis. Here we do not emit any carbon dioxide, but we produce solid carbon, which can either be used as a carbon black in tires, for example, or also be disposed of in a way that it is not emitted into the atmosphere in the long run. So blue hydrogen means that we have fossil fuels, and via a vapor reforming, we also create carbon dioxide, but it is being sequestered and being stored via CCS. And so this is also considered climate neutral hydrogen or low carbon hydrogen. The gray hydrogen is the one that we produce today based on fossil fuels, and the pink, or some also call it red hydrogen, is the one that stems from electrolysis, but the electricity source is nuclear power. In particular, in France, this is a concept that is being favored, and also in Hungary, they think about this concept. So this means that within Europe, we have a concept which can actually be discussed when it comes to climate neutral hydrogen. Now we have the climate neutral hydrogen, which can not decarbonize all different areas alone. This is why we also talk about hydrogen and the synthetic follow-up products. And this is just an overview over the synthetic products that we can talk about. Here you can see in the upper part the production of hydrogen by electrolysis. And then, of course, you need a carbon source, which is carbon dioxide in this case, which via different processes can be used in order to create the different products. Either you can use it as a synthetic or synthesis gas, and via Fischer-Tropsch catalysis, you can turn it into different products so that you have a synthetic derivative, which is similar to crude oil, but climate neutral and can be further processed in refineries, for example, like crude oil today, to kerosene, gasoline, or others. But you can also use a different kind of process and go via methanol, and via methanol, you can turn it into different derivatives and produce different chemical basic materials and turn it into gasoline, for example, or other products that can be used as synthetic fuel. So these are actually the synthetic products that are being synthesized in these processes. So now, once again, the question, why do we intensively talk about hydrogen? And I think the key word here is climate neutrality. And what does climate neutrality actually mean? In Germany, we have our climate scenario and also the climate targets that were laid out in 2010 already. So by 2050, we want to reduce our greenhouse gas emissions by 80% by then. The problem is that we were always focused on this minus 80%, and there you can see that there are still some emissions allowed in certain areas, which are quite relevant. So process emissions would only have to be reduced by 51%, also the industrial energy emissions only by 72%, and transportation would have had to reduce the emissions by 73%. And there was hardly any area where we exactly reached an 80% reduction in this scenario. Now we have a different scenario, which is really a climate neutral scenario, which means that we would have to reduce our emissions by 95%. And the remaining 5% can hopefully be achieved through carbon sinks, so that we have a net zero at the end. And here you can see the big challenges in the different areas that are connected here. So the energy and transformation sector, minus 100%, transportation, minus 100%, households and others, minus 100%, industry, energy emissions, minus 99%, and the process emissions, minus 87%. And this is actually the main challenge, which without hydrogen and its synthetic subsequent substances will not be achievable. The climate neutral production within industry and the energy intensive sectors like steel, chemical industry, petrochemical industry will not be feasible. And also in the field of transportation, and also in aviation and international shipping industry, without hydrogen and without synthetic subsequent substances like synthetic kerosene or synthetic diesel for the ships will not be achievable. And equally, the climate neutral electricity and process heat supply will not be possible without hydrogen. And so far, climate neutrality is actually the key why we have to debate hydrogen so intensively and why we will see more hydrogen in the future. And it will be more than just a raw material, but also play a very important role in our energy system.
So now it's up to you, and please let's have your questions. Thank you so far, and thank you also for the last slide. Hydrogen is the game changer for climate neutrality, and that's why we are talking about it in this introduction as well. And I also took on board that we need a lot of electricity for green hydrogen production, and so electrolysis. And I noted 3,000 terawatts for the industry alone. That's the electricity consumption in Europe. So we have to build a lot of solar installations and make a lot of savings as well to make it work. And we have a couple of questions already in our question and answer pool. And I would take a question from the chat. The question was, today, where is a blue hydrogen produced already? Where is it working, and to what scale? So where is a blue hydrogen produced? According to my knowledge, blue hydrogen is not produced yet. I know there have been announcements in Norway to produce blue hydrogen because Norway has, well, their natural gas fields are coming to an end, and therefore they are pressing carbon dioxide into the ocean floor. And I don't know that it's happening already on a large scale. I also know that the Netherlands are interested in blue hydrogen and in providing it, because they have the same problem with the existing natural gas fields that can be used to press carbon dioxide into the ocean floor relatively easily. But I cannot make any give any information on blue hydrogen that's existing or being produced today. So what we need today, we are still in the planning. What about green hydrogen? Is that being produced already at a relevant scale? Green hydrogen is exclusively being produced in pilot installations and for demonstration purposes, but we have a number of installations. But to give you a number, it's about 50 megawatts electrolysis performance. It's being installed in Germany already. And if you think about the 500,000 megawatts that we need in order to achieve the numbers needed for today, then you get a picture of the task. And it's at the moment today, we only have installations for demonstrations. The marketing is already being done, but it's not on a required scale. But now we get the political questions as well. Green, blue hydrogen. We are talking about it a lot, but it's not here yet. There is another question. Is it realistic that in a relative short period we can produce green hydrogen in order to become climate neutral, or do we have to use other hydrogen colors? What's your estimation? It's a very important question, because we are in a situation with the hydrogen that we haven't known yet, and we don't have any hydrogen other than the hydrogen requirements that the industry has today. We want to establish it in other areas, but we first need to have the applications, for example, fuel cells in heavy goods transport or in steel production, which I will come to in the second part. This will only be done, certainly, if it's clear for the industrial partners that they will get the required hydrogen, and they won't care whether it's green or blue. They just need the hydrogen to safeguard their business models. And on the other hand, we know that we have to develop the production part for hydrogen, for electrolysis, and to come to a series production. And we have to, in parallel, build up this production path. And that means also before we have to build up the renewable electricity production generation. And so that's where I can imagine that it would be necessary indeed to go back to other hydrogen colors in order to make this first step until 2030. But in my opinion, it's also quite critical if we think of blue hydrogen. It's quite likely that we need to build up the CO2, the carbon dioxide infrastructure, the transport infrastructure, the pipeline that that takes sometimes decades to build up, and then also to pay for in decades. And so you have to make sure that you don't choose the colors that even if you have enough green hydrogen in future, that you still have to serve the other colors because you have the infrastructure. And so if you have built the infrastructure, you have to finance it for years. And there were also some questions regarding the transport infrastructure. For example, could we actually use the existing natural gas infrastructure? Could we transform it into hydrogen pipelines? And perhaps also the question, the losses in the efficiency, the energy inefficiency when it comes to pipelines. Well, if you transport or push hydrogen through the pipelines, you need a certain pressure, and you lose up to 10% in energy, clearly more than in natural gas, because the hydrogen has to be concentrated, comprised at a higher level. So this would be something that you have to take into account when you want to have the hydrogen infrastructure for transport, and also intensive elaborations also when it comes to a hydrogen backbone network and for Europe. And so there are the natural gas pipelines are foreseen for this, but it cannot be done without changes. And so when it comes to pipeline materials and switching stations, then there would be changes necessary, because the materials are very good for natural gas production, but it wouldn't work that well with hydrogen, because the materials aren't suitable for it. So it had to be adjusted. The pipelines have to be adjusted, but it would be easier to use an existing pipeline and make changes than to build a new pipeline network. That would take much more time. It would be easier to transform the existing networks. And and when it comes to the topic of admixtures, and the natural gas industries are saying 30%, up to 30% is not a problem. The existing network would be usable, but what about a mixture from hydrogen and natural gas is of a lower value than natural gas, then also a lower value than hydrogen, especially when it comes to the calorific efficiency, the calorific value. So the admixture is worsening, in my opinion. It's not a very good solution if you need especially a clean hydrogen for your applications. There was also a question. If you look at what about decentralized production structures? At the moment, hydrogen is being produced and used on site, the gray hydrogen. So what about the green hydrogen when it's being produced in a chemical installation, and you don't need an expensive infrastructure? Well, I can imagine that there will be a decentralized infrastructure for smaller demand sections, and this will be also the development until 2030, because we won't have any transport infrastructures for hydrogen. I think the hydrogen economy will develop from the decentralized level and then use the advantages that for example, electrolysis has additional energy, warmth, and heat. And so it can be used for also decentralized production, and supply for petrol stations is possible. And when it comes to ThyssenKrupp, I think the need for hydrogen, the demand is so large that you cannot do it with an on-site solution, but perhaps when it comes to offshore projects, maybe you have read about it in the media that RWE and BASF have a cooperation to use offshore wind installations directly for hydrogen production, meaning their electricity, and use it at BASF. But yeah, that's quite possible. But when it comes to large installations, large applications, is quite difficult, because the connection demand is very large also for electricity, and you need the required transport infrastructure. And you cannot solve it via decentralized solutions. We have two participants that wanted to connect via a video link. I can give you the questions, but perhaps they will also be covered tomorrow, but maybe Mrs. Schmidt can cover them today. Mr. Leonard Ganz, please switch on your video or your sound. Mr. Leonard Ganz. So Mr. Ganz has to allow us in, and yes, hello. So yes, thank you for giving me the opportunity and for the exciting presentation. My question relates to well, I have dealt with the climate problems, and when it comes to the discourse on hydrogen, it's always about e-mobility, electric mobility, even if it's not a central topic, but this is where the political debate focuses on. And the graphic, the graph that you showed, the energy demand by transport had a certain share. And what I understood is when it comes to individual passenger transport, that well, we should not waste the hydrogen in this area because it would be inefficient. But in this graph, is it already contained in it, or what would be the additional demand, or in your opinion? The way that I understood the hydrogen roadmap for Europe, I would say that in the individual transport and traffic, electric mobility will be the overwhelming share, meaning battery driven electric vehicles, and you can only achieve it with these electric battery vehicles, and so that would be emission free. But if you look at the development, you can see that the hydrogen vehicle does not really have that many advantages over the electrical vehicles, because the distance that the newer models can cover, the range they have is about 500 kilometers. A fuel cell vehicle can do it too, but it would be more demanding. And the only advantage is that you can fill up the tank much quicker in about 5 minutes. And with the normal, as with a normal vehicle, and that's not the case with an electric vehicle. So even when you do a fast charge, you need an hour or thereabouts, and therefore I would say that fuel cell vehicles for long distance are certainly included in this graph, but I think a large part of this individual transport is certainly covered with electric or battery-driven vehicles. And then we have a question from George Vasvaronix or George Dosteroni. Maybe you can give us your name, and you wanted to connect via video or audio as well. Yeah. Good evening. A very interesting presentation. The question is, how do we finance this development? How do you want to do it? By private investment or by tax money? And we have the green hydrogen on one hand, and we have to finance the production of green electricity plus the production of green hydrogen. So this is the basic question where we have a huge debate. Ultimately, we need both. I think we need private and public capital, and well, my idea would be the financial markets, but Mrs. Schmidt has probably her own ideas. Well, I think you put it quite well, and we will focus on it tomorrow in the hydrogen strategies. The European and the German politicians announced a large sum from public money, but if you look at the large, enormous sums that are needed, then I don't think that the public money, public finance will be sufficient. We need private capital as well in this area, and we can see that there are early efforts in this regard. If you look at the announcement of the BlackRock, the head of BlackRock, they will only invest in climate neutral areas in future. And so a lot of people are following this. And so I do see opportunities that there will be capital for such projects, but without the private investment, we will never achieve this hydrogen world. And therefore, the control of the financial streams have to go towards sustainable streams and investment. And well, the EU had to has tried to do it with their, green taxonomy, and but without private capital, it won't be possible. But then you have to make sure that there is a certain profitability guaranteed. That's certainly true. Without it, there's no chance. So there are also the first hydrogen EGSs now, and investment funds. And I don't want to consult on it, but if you look at the shares in companies that are active in hydrogen areas, I think there will be a lot of capital influx. And so there are a lot of important questions in the chat. Maybe there is there will be more questions tomorrow. There are a lot of questions regarding facts. What is the additional need in renewable electricity? How much do we have to produce until 2030? 2/3 in Germany, 2/3 of the required demand in Germany has to be produced until about 2030. A lot of these figures are focusing on facts, and maybe we will get it via Mrs. Schmidt's presentation, but we also have a fact sheet from the Böll Foundation, but maybe we will get some insights and answers in the second round with Mrs. Schmidt, and then we can also ask some more questions. And you can also connect via video if you want.
Screen sharing läuft.
So the screen sharing works. Okay, then we will continue with the second part, and this refers to the question, where is this hydrogen should be used most efficiently, can be used most efficiently. So this graph is a little bit difficult to decipher. I apologize for that. This is from the Hydrogen Council, from the Hydrogen Insights from this year, for those of you who would like to look it up. And you can find this graphic there. And the graphic basically says that there are areas in which there's no alternative to climate neutral hydrogen. For example, the methanol production, and this would also be a good use case today in terms of efficiency. Then we have, this would be the blue part, or the part that we see circled here. Then the orange section, the steel industry or refineries. There in the future, hydrogen will be without any alternative. But here we need an improvement in terms of green hydrogen in order to have an economic use case. Then there are also areas that are considered the areas with the biggest benefit, which is the area of different fuels, in particular in the field of forklift trucks or heavy duty trucks up to 40 tons, or trucks up to 20 tons, coaches, train traffic on non-electrified routes, or also off-road traffic for construction site vehicles, and also long distance passenger cars that we briefly touched upon in the discussion, and also taxi fleets. And also on the other side, we see the area for the synthetic downstream products, where it's the only alternative, which is for long haul flights, international maritime shipping, and also short haul flights, should we allow them in the future. So these are all areas where hydrogen is needed in the future if we want to maintain the system as it is today. I mean, if there are fundamental changes in the future, then the demand might no longer be there in the future. So this is what I would also want to add to the electricity demand. of today. I mean, if we calculate that we process fewer hydrocarbons or no hydrocarbons anymore in the refineries in the future, then of course the refineries will not need that much hydrogen in the future anymore. So the whole system might shift in the future, but what we still have as refineries in the future will need green hydrogen, definitely, and also synthetic products. The area of heating is not so well suited, so low temperature heat, and also the area of passenger cars and ferries are not that well suited. And gas turbines, yes, if you use them or need them as a backup technology, but not primarily as an application for hydrogen. This is actually what the Hydrogen Council recommends or says. Let's take a look at the industry. Climate protection and hydrogen applications in industry. Here there are three examples: ThyssenKrupp and Duisburg, who emit 8.3 million tons of carbon dioxide at their location. BASF in Ludwigshafen, that produces 6.6 million tons of carbon dioxide, and the refinery in Karlsruhe that creates 2.7 million tons carbon dioxide. So these are values from 2018 or figures from 2018, but I'm assuming that they're still representative. So with these examples, you can see that the industry actually has a huge share in the carbon dioxide emissions in our country. And here we see a chemical industry 2%, iron and steel 4%, refineries 3%. So this means that if we would use new technologies here like hydrogen, and if we made huge progress here, then of course we would also be able to very quickly cut the carbon dioxide emissions in these sectors and go further into the direction of climate neutrality in these sectors. This is very important because these segments have long lifespans when it comes to their plants, in particular when it comes to blast furnaces, steam crackers, or cement kilns. They have a very long lifespan of sometimes 50 years or more, and have a high capital need, capex need at the beginning. So this is why it's so important, if additional investments are being made, that they are invested in climate neutral technologies, because otherwise we will not be able to become climate neutral in these sectors by 2050. This is why they also need to have hydrogen available in order to be able to transform and take these transformative steps. This is why we also need these important innovations called leap innovations, where we use completely new processes like hydrogen, and hydrogen plays a very important role here because in comparison to the other sectors, we have only few alternatives for the industry. Let's take a closer look at the situation. Here we have a kiln. Usually nowadays, coal is used, or coke is used to reduce the iron ore in direct reduction plants. And we also see a process-related carbon dioxide emissions. And in the alternative, the direct reduction, we have or can use green hydrogen. And in the end, we have iron and water. So this means that the carbon dioxide emissions within the process can be reduced by approximately 97%. So in the end of this process, of course, you still need a little bit of carbon in order to guarantee the quality of the product. This is why you cannot become 100% climate neutral, but a reduction by 97% is quite a remarkable step, and a good step into the right direction towards a climate neutral production. This is already been tested. You might already have seen this in the media. So the Salzgitter AG is already testing the respective electrolyzers. And here we have the 2.2 megawatt PEM electrolyzer. And Siemens was commissioned with the building of it, but you can already assess that 2.2 megawatt is actually a pilot plant, and they simply want to check whether the technology is working before they start with large-scale processes. But it's going to be without any alternatives if we want to continue to produce steel in Germany. And I think the people responsible here, the stakeholders, know that. Another example is the so-called MIRO concept, the mineral oil Upper Rhine refinery. And their objective is to become climate neutral as a refinery. And on the left-hand side, you can see the situation today. So there's crude oil being transported, and at the Miro in Karlsruhe, it is being refined in the refinery and turned into the respective products, is then being used, and in the consumption or utilization, carbon dioxide is being emitted. And in the future, the objective is to use electricity from renewables and to develop synthetic liquid energy raw materials, which are so-called green crude. So a oil replacement can be transported to the Miro and then be turned into the products that we know today. So the refining process can be maintained, and also the value creation chain. And the Miro is also planning for a demonstration or pilot plant. And in this demo plant, synthetic fuels will be produced in order to show that the concept works. And the concept for the industrialization, which needs a scaling of 1 to 10, can then be implemented. And the Miro, of course, is not the only refinery. There are different refineries and different locations where we see similar activities ongoing. And maybe one or the other of you has read in the media an article about the location Werther and the first synthetic kerosene. So here we can already assess that first steps into this direction are being taken. Then, of course, we have the transportation sector, where hydrogen might be used as a key technology in order to become climate neutral. We already touched upon passenger cars, and I think that the respective development in terms of batteries and the battery electric vehicles are well ahead of the fuel cell producers, but still there are some use cases where fuel cells are actually of good use. For example, trucks, coaches, or also trains, as I've already mentioned in the first half of this seminar. And then, of course, the synthetic subsequent products for air traffic and also international maritime transport. Let's take a look at the question how much it will be in the end. So here we have a graphic how the end energy demand might be in the year 2050. And it will be approximately at the level of 600 terawatt hours. And we assume that large parts of it, or a large part of the passenger cars, will be run by electric batteries. So in the end, we will have 300 terawatt hours for the train traffic and also maritime transportation that we would have to cover. So how can it look like? In the field of fuel cells, there are some developments already, in particular when it comes to forklift trucks or industrial trucks. And there are approximately 12,000 already being used at the moment next to battery electric vehicles, always depending on the respective field of operation. And either we have a fuel cell or battery electric or the conventional forklift shaft. And also in the field of light commercial vehicles, we have these kind of technologies, and you can see that Hyundai has or wants to put many thousand fuel cells on the Swiss market. Why did they choose Switzerland for the heavy commercial vehicles? Switzerland has some exceptions for fuel cell run vehicles in terms of the carbon dioxide pricing. And this is also the reason why the first technological rollout takes place in Switzerland. Vehicles for a police and fire brigade. This is the Toyota Mirai, for example, that you can see. So in this area, we also see pilot projects that are already taking place. And below, you can see a hydrogen bus, public transport bus. And this is what we can already see today. So as a technology, it's developed or in a development stage that we can also see the applications. And also when it comes to trains, also public transport trains, we see trains that are being tested in practice, and also the garbage collection trucks can also be used based on fuel cells. And of course, for all these applications, we need a refueling infrastructure. And this is actually the main challenge, which is not yet solved today. Then, of course, we also have the area of synthetic fuels. We already touched upon that, and this is why I do not want to go into much detail here, but for long distance traveling, we see predominantly airplanes with hydrocarbons in the future. And there are two concepts at the bottom, the high to fly, where hydrogen is being tested in the aviation field. And it's, of course, good to further test and do research in this regard. But by 2030, and actually also by 2050, we will probably not see long distance airplanes or long distance flights based on hydrogen. The electrolysis that you need for synthetic fuels, of course, can also be made available for hydrogen. So this means that we have fewer efficiency losses. So the investments into hydrogen are actually good and of no regret, so to speak. So tomorrow we'll talk in more detail about the hydrogen strategies at the national level and also in Europe. The roadmaps stipulate certain targets. In Germany, by the year 2020, we have less than 0.1 gigawatt electrolysis capacity. And by the year 2030, we want to reach 5 gigawatt. Within the EU, we see a similar picture. We have within the EU in 2020, less than 1 gigawatt, so less than 1,000 less than 1 gigawatt electrolysis, and by 2030 we would like to reach 40 gigawatt. And of course, this also involves a certain revenue potential. At the European level, approximately 35 billion euros, in Germany 4.5 billion euros. And on the right-hand side, you can see the development potential. Of course, a lot of revenue can be generated when you are in the lead in this technological segment. And so far, it's quite clear that Germany and also Europe want to play a leading role in the hydrogen sector because it will generate jobs in the future. However, the main challenges lie in this rapid build-up of the electrolysis capacity, because the electrolysis at the moment is at the manufacturing level between 1 to 10 megawatts per plant. This means that we first of all have to scale the technology, and in parallel, simultaneously, we have to come to a serious production in order to be able to cater for the envisioned network. And of course, we are not alone. We are in an international competition. And this is why it is quite an exciting environment and sector. As you can see here, the electrolysis and power-to-X applications, we have successfully demonstrated in practice in a large number of pilot projects that it works, but at the global scale, there are only 10 suppliers approximately of electrolysis plants in the megawatt range. And so this means that in Europe, we have to try to keep up. And we also have to prepare the companies so that they are capable of participating in this market. In America and also in Asia, there are also producers who want to grow and who want to participate in these markets. And also China has set itself respective targets in its 5-year plan. And by 2030, it wants to install many megawatts or gigawatts of electrolysis capacity. So we do not only see changes in Europe, but also elsewhere. And now I would like to announce an event from the FVEE, the Research Association for Renewable Energy, or Renewable Energy Research Association, with hydrogen to climate neutrality, from research into practical applications. So if you're interested in, you can participate here, and the respective application forms, etc., can be found on the website that I have indicated here. It would be great to see you again there.
Many thanks, Mrs. Schmidt. Once we have had this introduction, I think we are ready for the next event, for the further events. I think it's a good follow-up. So we've received a few questions, but nobody has announced the video connection, and you can also, the international guests, you can enter your questions in English in the question and answer tool and get connected. Mrs. Schmidt, we have received several questions. Let's get started with the complex of sector coupling. And the question on one hand, how does hydrogen work as an energy carrier? How can it be used? Could it also be used in vehicle engines? Yes, the concept of a vehicle engines has been developed already in 2007 by BMW, but they gave up because for reasons of efficiency, also for reasons because the tank couldn't be really made tight enough, and there were a lot of losses. So, but the concept is still being discussed and also being forced by truck producers. And when it comes to hydrogen engines, it's not really wrong. The hydrogen engine concept in a lorry or a fuel cell, the decision hasn't been made. There could also be parallel applications, but you have to make sure that the refueling infrastructure is also makes it possible to support both paths, and you don't get stranded investments and build up a wrong technology. So this is a challenge, really. But it's also the case that it's quite undecided. It depends on, which producer you talk to, and the hydrogen engine would have the advantage that the production process does not have to be adjusted very much, and it could be transformed quicker. And on the other hand, it's not emission free because you still have a combustion process. It is CO2 neutral, but you still have other emission products. And so this is not an advantage really of the hydrogen engine, but it's an interesting technology that's certainly being pursued by some producers, but you have to see what happens. And if we don't make the expected advantages, then we will have to build up another technology. Also question why is not hydrogen not used for private vehicles? Because we talked about fuel cell vehicles as well. In my opinion, there are no available models on the market. There are electrical vehicles, and but most producers have agreed on this technology path. Mainly VW. It's certainly the biggest promoter of battery electrical drives. And yes, at the moment, especially from the Asian region, there are some models by Toyota and Hyundai. But the question is justified, because in the Chinese 5-year plan, they are targeting fuel cell vehicles, because in their million inhabitant cities, you have to have an alternative for charging millions of vehicles, because in Germany we have a relatively stable electricity network, and with the required technology, with the charging technology, we can certainly stabilize the system. And but it's an important point when it comes to electrification of buses in public transport. And we also have the question here, which technology, fuel cells or batteries? So the uncoupling of energy charging, if you can refuel quickly and don't have to spend hours on the charging network, it can be an advantage, especially when you have big bus fleets and that you want to charge quickly. That will be difficult to do it with the electricity network. This is where the fuel cell and hydrogen engine also have an advantage. You can't give a general answer here. You have to see what the situation requires, and therefore you need parallel developments. Then there was a question regarding trains. One person asked, why is hydrogen envisaged for trains? Because the railways rejected usage of hydrogen trains categorically. I think in northern Germany there is a track for hydrogen trains. So why do you talk about hydrogen? Because we already have electrification of trains. Well, more than 60% of the train tracks in Germany are electrified already. The rest is being done via diesel engines, but it's not worthwhile to electrify all train tracks, and especially where the utilization is not as high. This is where a fuel cell truck could be an alternative, train could be an alternative. But it depends on the market, really. And you're right, the electrification, in most cases, the direct electrification makes more sense. But for ecological reasons, it can be that it's not economic, and therefore we need a replacement. Then we had a remark. Perhaps I can take it as a final remark. One person, because it's 7:15 already, one person pointed out that the buildup of a hydrogen economy including electrolysis installations, etc. All the plants and installations that are being needed require a lot of resources, natural resources, metal, and then the metal production is also connected to human rights abuses, and there are unfair trade relations. And this person points out that when you talk about climate neutrality, there are a lot of side effects in this system. And it's also about, when we talk about green hydrogen, we have to consider the end of pipe, that in the value creation chain, there are side effects. And I wanted to add that these investments will always happen also when it comes to other hydrogen types, with the blue, the yellow, and gray. And if you look at the value creation chain, then the green, the investments are the smallest, really, with the green hydrogen. If you look at the overall value creation of the different hydrogen colors, you can say that the green hydrogen overall is a good thing. Well, I would say it without having calculated it, because you don't use fossil energy resources, and especially when you use methane, you have additional problems, uncontrolled methane emissions. And but I think the topic that was mentioned is quite important. In this discussion on climate neutrality, we should not neglect the other sustainability goals. We have to pursue them at the same time. If we want to come to a climate neutral world, these points have to be included. That especially goes for the potential hydrogen import, and when it's about where is it being produced, where do we build partnerships with which countries. So the idea of neo-colonialism comes up very quickly, and we want to avoid this in any case. And it's not about, as we've done it in the past with fossil energy sources, we want to have partnerships on the same level, on a level playing field, and so that the states can also benefit from the hydrogen production and have their own value creation. And then we would be, at the end, we would be the importers of hydrogen. So this would be something that we have to make clear for ourselves, that so that it's a project that we can use as such. And the problem today is that we have a non-climate neutral production, and in future this will hopefully be improved, and the more renewable electricity we have, of course, then the smaller the footprint will be in raw materials production. But that will have to be seen. And there was another post, economy, ecology, and social neutrality has to be joined, and this is a good aspect that we want to talk about tomorrow, that we will have a social neutral value creation chain, and we have to think about what we can do here in Germany to get this sustainable triangle in Germany. Many thanks for your questions and your comments, and I thank you very much, Mrs. Maike Schmidt, for taking the time tonight. And I look forward to tomorrow, and I would be happy if more people would join us via video. It can be a bit more relaxed that way. Have a nice evening, and we hope to see you again tomorrow. Thank you.